Good morning, everybody. With you, Mr. Sharif Abbas, and today, inshallah, we will explain lesson for grade 7, chapter 8, lesson 5, light. Okay, first, we know the light, it's a kind of energy. The light composed from photons. Photons, it is a particles which have an energy, but they doesn't have any mass. Okay, if the light phase any object, so this object must be one from three things. Maybe it will be transparent object, or translucent object, or opaque object. Okay. Wording of transparent mean that the material that transmit most of light that strike. Okay, it's look like a glass, like my glass, which right now, this glass is, okay, the light can move through it. All the light, or almost all the light, can move through it. So we call it transparent. I can see from it clearly. Okay, the second one, translucent. And translucent, it's a material scatter the light that pass through it. That means not all of the light can move through it. Like waxed paper or some kinds of plastic. Okay, we can see from it, like a tissue, we can see, but we can't see clearly. And the last one, it is opaque object, and this opaque object, that means the material of the light, the light when it is go to opaque object, it maybe reflect, or this object absorb all kind of light, like the wall or the board behind me. Okay. After that, what is the color of object? How we can see the color of object? If you want to speak about the color of object, how I can see as a symbol the green color. Okay, the green color, that means this t-shirt or any kind of clothes or any object, that means this object absorb all the color and reflect only the green, so I can see it green. Okay, if we have another things like a blue t-shirt, so that means this t-shirt absorb all the colors and reflect only blue. What about yellow? The same thing. Okay, there is some kinds of colors, not main color, that come from combination between two or more different colors, like brown. Brown is a color come from red and green. Okay, so when I see the brown color, brown t-shirt or brown object, that means this object absorb all kinds of color, okay, and reflect only red and green, so I can see it brown. Okay, and here as example, we have here a ball. This ball composed from two colors, blue and red. Okay, at the white color, I can see both of them. Why? Because white color of this object, white color reflect all the white color, so I can see the blue and I can see the red at the white color. But what will happen if I close the white color and open a blue light on this ball? What will happen? As the blue one, the blue parts from this ball, it will absorb all the light and reflect blue, because it's blue light, so it will reflect blue, I can see it. But the red one, it is absorbed blue, so I will see it dark, I will see it black one. But if I put this ball in red light, as you see at the picture, what will happen here? The blue one absorbed the red light and it seemed to black, and the red parts reflect the red light and I see it red. If I choose another light, not red and not blue, like a green, I will see all the ball with black, because both of them, red and blue, absorb the green color. That is the idea. It's very easy and very simple. Okay, so the scientists make something, we call it color filters. Color filters, it make us to see the things from one color. Okay, the color of light might come from white light shining through a colored filter. So I can see, for example, at this picture here, guys, we have a man with a red t-shirt, okay, in a something like a forest, all of green. So I have some kinds of filter. This filter it make me to see only the red color. So when I put it in my cam, I can see only the man with red. And all look to the picture, look to the picture, and the forest behind him, it is look black thing. But if I choose another kind of filter, well, like a green filter, so I can see the forest, but I can't see the color of the t-shirt of this man. That is the idea. Okay. Now we will speak about reflection light. We speak about reflection before, and we know that the reflection when the light hit a surface and bounce off. That is a reflection of the light. Okay. We have here two kinds of reflection. The first one we call it regular reflection. Regular reflection, and it's occur when a parallel rays of light hit a smooth surface. It must be smooth. So when the light hit a smooth surface like a mirror, it is make for us regular reflection. That means we can see a clear image. Okay, why? Because the rays of reflection, as you see here, rays of reflection, okay, at the same angle, so we can see a clear image. Look at this image, okay, we can see the mountain reflection from the water surface because this water, there is no wind, so it doesn't move, so I can see a clear image for the mountain as a reflection. Okay, but what will happen if we have a rough or a choppy water here? Choppy water or a rough surface, any kind of surface, rough surface. Look to the rays. It will not be parallel. So I have here another kind of reflection, and we call it diffuse reflection. So the diffuse reflection, parallel rays of light hit an uneven surface. The angle at which each ray hits the surface equal the angle at which it reflects. So the rays don't bounce off in the same direction. So I will not see a clear image or clear photo. Okay. Now we have the most important part. The mirror and the lenses. First, what is a kind of mirror? Guys, we have three kinds of mirror. Focus. The first kind of mirror, it is plane mirror. Look to my hand. Plane mirror. Okay, plane mirror. Second one, it is concave mirror, like a plate. Okay, the same thing of spoon, like the spoon, the part which we eat from it. That is a concave. And we have convex. That is the other part from the spoon which we don't eat with it. We call it convex. So the kind of mirror we have: plane, concave, convex. Plane, concave, convex. Sorry. So the plane mirror and flat mirror. What is the important thing which must know here? At every kind of mirror or lenses, we must know the shape of it and the image. If we want to see an object through it or from it, okay, what is the properties of this image? Okay, let's begin with the plane mirror. The plane mirror gave us virtual image, as you see as a picture, virtual image and upright, okay, and the same size, and reverse it. Virtual, it's mean not real. Why? Because we see the image inside the mirror. So, of course, it's not real. It's virtual. Okay. Upright, that's mean the head is up and the leg is down. It is upright. Okay. The same size, it's the same size, not bigger, not smaller. And reverse it, that's mean when I lift my right hand at the image, it will be the left hand, not right. So that's mean we have reversed image. That is the properties of the image which come from the mirror. Okay. What about convex mirror? The convex mirror, We know that the convex, it's this part of the spoon, the X part, convex X, we can't eat from it. Okay, the convex mirror, guys, it have a different kinds of what? Of properties. Look, that is the convex mirror. But before we know what the convex mirror properties, we have here some important part. That is optical axis. What is the optical axis? Optical axis, it is imaginary axis which divide our mirror to two halves or two parts, okay? Exactly from the half. That is optical axis. And we have a focal point. What is a focal point? Focal point, it is a location at which ray parallel to the optical axis and reflect and meet, okay? When the rays meet at the point, we call this point focal point. When the rays reflect and meet inside one point, this point, we call it focal point. Okay. And of course, this focal point, we found it on the optical axis. Okay. So, what we see when we use a convex mirror, when we use a convex mirror, we see an image, it must be smaller. It must be what, guys? Smaller and virtual. Smaller and virtual, like the mirror which we use inside our cars. Okay, it's smaller and virtual, but at wide angle, so I can see a lot of things around me. What about concave mirror? Concave mirror, that means this mirror curves inward. Inward, that means like the spoon, the part which we eat with it. Okay, that's a concave. The concave mirror have two cases for image. If the object between the focal point, look here at the drawing, if the object here, okay, between the focal point and this is the focal point here, that's the focal point and the lens, okay, the mirror, or the object farther than the focal point, like here. Let's speak about the first case. At the first case, when we put the object between the focal point and the lens, it gives us image, virtual image, and virtual, it's mean not inverted, and it will be bigger, like this photo, like this. It is near the focal, between the focal and the mirror itself, so give us virtual photo, virtual image, and it is bigger, okay? You can see it at the hotels. Okay. And second part, if we put an object after the focal point. So what will happen? Now we will see inverted image. What's the meaning of inverted? Inverted image, it's mean real image. How it's real? Because the image would be at the same side of the object. So if we have here the object, the image will be here. We'll change the color. Okay, that is the object, and the image will be here at the same size. Okay, guys. So if we put the object between focal and the mirror, it gives us a virtual and bigger image. Okay, but if we put the object after the focal point, it gives us what? Give us real image and upside down, as you see at this picture. That is a real image. Okay, but you must know that, guys, the mirror here is different than the lenses. At the real image, at the mirror, real image, the object and the image will be at the same size. But okay, guys, now we will speak about lenses. Lenses, it is a curved piece of transparent material that refracts light. Refract, not reflect. The mirror reflects the light. Reflect, but the lens, no, it is refract. That means the direction of the rays of the light will change, okay, when it is go through a lens. Okay, how many kinds of lenses we have? We have different kinds of lenses, but we will study only two. convex lenses, and concave lenses. Okay, what's the difference between them? Look, that's the first one. Convex lens, it will be thick at the middle and thin at the edge. That is convex. Okay, convex. Okay, what about concave? It will be thin at the middle, thick at the edge. That is a concave. Concave. Okay. Let's start with a convex lens. The convex lens can produce virtual image and real image. How? Look guys, and focus at this drawing because it will come inshallah at the test. We have here two cases. Here you must know that first thing, the real image must be at the next side from the lens. Look, we have here the object. That is the object. Okay. When the rays it's move, it make for us an image at a next side. So that is a real image. It's different than what, guys? Different than the mirror. The mirror we found the image inside the mirror, we call it virtual, but here we call it real. Okay, what about virtual image? The virtual image, it must be the image at the same side. That's the image, the same side of object. The image must be what? The same side of object. So, what is the two cases here at the convex lens? The first case, if we put the object between the focal point and the lens, that is the object between them, so we have a virtual image. It will be upright and bigger. Upright and bigger. Look to the pencil. It is bigger. The image is bigger, and it's the same way that's being upright. Okay. What about if we put the object after the focal? That's the focal, and we put the object here after the focal point. So we will have a real image, and this image will be smaller, maybe the same size, maybe bigger. Okay, if we move further than the focal, it will change at the size, but it must be real at the next side, and it must be upside down. It must be what, guys? Upside down. Okay. If you note that the rays at the convex lens, it's bent toward the optical axis. Look, it's bent toward the optical axis always. But now, when we speak about concave lens, it is different. We know that the concave lens, it is thin at the middle, as you see, and thick at the edge. Okay. When the light travel through this kind of lens, concave lens, it is the rays bent away from the optical axis. Look, the rays bent away. Okay. So guys, because the rays, and they are never met, the rays here never met. So because the rays never met, concave lens form only one kind of image. It's virtual image only. They can't make real image. Okay? And this image, it must be upright and smaller than the object. If we put the object after the focal point, or like here, like the first example, or we put it between the focal point and the lens, okay? At the both cases, we have a virtual image, smaller and upright. That is the properties of the image at the concave lens, and I think that is our lesson. I hope you understand it. It's very easy, and see you again.